Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 9 students and the topic of discussion is quadrilaterals. So what is a quadrilateral? Quadrilateral is a four-sided figure with four angles and four vertices. Vertices are the corner points. So square is a quadrilateral. All sides equal and all angles are 90 degree. Similarly, rectangle is a quadrilateral where opposite sides are equal. So these two blue colors are equal and these two red color sides are equal and all angles are 90 degree. A parallelogram is also a quadrilateral with opposite sides being equal and parallel. Trapezium, at least one pair of sides are parallel, so this is parallel to this. And a rhombus, all sides are equal and opposite sides are parallel. And another important thing of a rhombus is that the diagonals of a rhombus bisect at 90 degrees. Let us try to understand few theorems on quadrilaterals. A diagonal of a parallelogram divides it into two congruent triangles. So ABCD is a quadrilateral or a parallelogram. And if we draw the diagonal AC, then we need to show that the triangle ABC and triangle ADC are similar or congruent. Let us try to prove this. We know that the alternate interior angles are equal. So this angle BAC is equal to angle DCA marked by these double curves. Similarly, angle DAC is equal to angle BCA marked by single curves here. AC is common to both the triangles. So two angles and one side is equal. So by ASA criteria, the two triangles ABC and triangle ADC are congruent as well as similar. So once we have proven that these two triangles are similar, we can always say that AB is equal to CD and also AD equal to BC by CPCT rule. So we can derive an alternate theorem that in a parallelogram opposite sides are equal. So if ABCD is a parallelogram, AB will be equal to CD and BC will be equal to AD. Another theorem, if each pair of opposite sides of a quadrilateral is equal, it means DC is equal to AB and DA is equal to CB. If this pair of sides, opposite sides of a quadrilateral are equal, then it is a parallelogram. Then we need to show that ABCD is a parallelogram. So if we see these two triangles, triangle ACD and triangle ABC, we see that these two sides are equal. AD is equal to BC and similarly CD equal to AB. It is given. AC is common. So these two triangles through side or SSS congruence rule, these two triangles are similar. If these two triangles are similar, we know that through CPCT angle ACD is equal to angle BAC. Let us try to draw that. This angle is equal to this. Similarly, this angle will be equal to this angle. Through CPCT rule, since these two triangles are similar. So, but they are the alternate angles. These two, if we see, are the alternate angles if DC is parallel to AB and AC is the transversal. Since these angles are equal, we can say that DC is parallel to AB and AC is the transversal. Similarly, we can also show AD equal to BC. Hence, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Hence, ABCD is a parallelogram. We have shown that. In a parallelogram, opposite angles are equal. If in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. It is easy to prove this. In a parallelogram, opposite angles are equal. We already know if it is a parallelogram, AD is parallel to BC and AC is the transversal, and these two angles are equal. Let this be X, and this be X, and let this be Y, and this be Y. So they are equal. Why they are equal? Because AD is parallel to BC and AC is the transversal. We have seen it earlier. So this angle DAC will be equal to BCA will be X. Similarly, this Y will be equal. Now it is telling in a parallelogram opposite angles are equal. Let us, this full angle will take. That will be X plus Y, and this full angle will be X plus Y. So both are equal. So the opposite angles of a parallelogram are equal. So angle DAB is equal to angle BCD. So opposite angles are equal for a quadrilateral. Take another theorem. The diagonals of a parallelogram bisect each other. So this is a parallelogram. DB and AC are the diagonals. So they bisect each other. They bisect each other means they divide it into equal parts. So OD will be equal to OB and OA will be equal to OC. So we need to show that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. We are given OD equal to OB and OA equal to OC. Then we need to show that ABCD is a parallelogram. Let us try to do this. Let us take two triangles AOD and BOC. And BOC, these two triangles will take and try to prove them to be similar. Already this side is equal to this side and this side is equal to this. It's already given, and this angle is equal to this. So angle AOD equal to angle BOC. Why it is vertically opposite angle? These two are vertically opposite angle. These sides are equal. They are given. So these two triangles are similar. Why they are similar? Two sides and one angle are equal. So SAS criteria, they are equal. They are similar. So AD equal to BC by CPCT. So AD will be equal to BC by CPCT, and angle ADO will be equal to CBO will be equal to CBO. So this angle will be equal. This angle will be equal. These two angles will be equal. These two angles will be equal. But they form a pair of equal alternate angles. They are a pair of equal alternate angles. So it means AD is parallel to BC. So we have shown that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Now we take a rhombus here. In a rhombus, the diagonals bisect. Diagonals of a rhombus are perpendicular to each other. We need to show that. So ABCD is a rhombus. Rhombus means all the sides are equal. And they also bisect each other. So OA will be equal to OC and OD will be equal to OB. This is the property of a rhombus. We need to show that the diagonals of a rhombus are perpendicular to each other. We need to show that this angle is 90 degrees. For example, COD will be 90 degrees. If we can show that, we have proven this. Now let us take these two triangles, AOD and COD. Let us take these two triangles. These two sides are equal in that. OD is common in that. and also AD is equal to DC. The sides of a rhombus are equal. So by SSS criteria, by side congruence rule, these two triangles AOD and COD are congruent or similar. These two triangles are similar. If they are similar, then by CPCT, angle AOD is equal to angle COD. Let us define that. This angle is equal to this angle. Let it call by, we call them by X. So this is X, this is X. They both are equal. Why they are equal? By CPCT criteria. Since these two triangles are similar, their corresponding angles are also equal. So this angle AOD will be equal to angle COD. Both will be equal, and let it be X. Now this angle, since AOC is a straight line, the sum of angles X plus X in a straight line forms a linear pair. So X plus X will be 180 degree. 2X will be 180 degrees. So X will be 180 by 2, 90 degrees. Each of these angle is 90 degrees. So angle COD is 90 degrees. That's what we proved now. Angle AOD will be equal to angle COD, 90 degrees. So the diagonals AC and BD are perpendicular to each other. So we have shown that. Next we come to a midpoint theorem. This is very important. In your exam, generally you get a problem from this theorem. So let us try to understand what this theorem says. The midpoint theorem says the line segment joining the midpoints of two sides of a triangle. So AB and AC, E and F are the midpoints of these two sides. So AE equal to EB and AF equal to FC. We are given that these two are the midpoints, and suppose we join that EF. We need to show that EF is parallel to BC. EF is parallel to BC, and also EF equal to half of BC. So this we need to show. So how do we proceed? First we draw a line CD parallel to AAB. So this is by construction, we are drawing a line parallel to this AB. So CD is parallel to AB through construction. And we extend the line EF till point D. So now let us consider these two triangles, triangle AEF and triangle CDF. So we try to consider these two triangles. Now angle EAF equal to FCD. EAF equal to FCD. Why they are equal? Alternate interior angles. So let us draw that. This angle is equal to this. These two angles, they are equal. Alternate interior angle EAF equal to FCD. These two angles are equal. This is the transversal. AB and CD are parallel. This is the transversal. So alternate interior angles are equal. AF equal to FC. This is true. AF is equal to FC. Why? Because F is the midpoint of side AC. And angle AFE. AFE. Let us draw that also. This angle is also equal to this angle. Vertically opposite angles. So two angles and one side is equal in these two. So we can say that AEF is similar to CDF. AEF is equal to CDF. So they are similar. Now by CPCT, EF equal to DF, EF equal to DF. These two are also equal. And AE equal to CD. So these two are also equal. A is equal to CD. Also B equal to AE, B equal to AE is the midpoint, and this is equal to CD. Now B equal to CD, opposite sides of a parallelogram are equal, hence BCD is a parallelogram. ED parallel to BC, ED parallel to BC, opposite sides of a parallelogram are parallel. EF parallel to BC. Since ED is parallel to BC, EF is also parallel to BC. Therefore, EF equal to DF. EF equal to DF. So these two are also equal. EF is equal to DF. Now EF plus DF equal to ED, but ED is equal to BC. That's what written. EF plus DF equal to ED, which is nothing but BC. So 2 times EF, DF is equal to EF. So we can write 2 times EF equal to BC. So EF equal to half of BC. Hence we have shown that if the line segment joining the midpoints of two sides of a triangle is parallel, E and F are the midpoints of two sides AB and CD. If we join them, it will be parallel to the third side BC. EF is parallel to BC and EF equal to half of BC. Friends, with this we conclude this video. Please like my video and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.